Hello everybody, good morning. I hope you can hear me loud and clear. If you cannot, just raise your hand and I'll try to fix something. Alright, so welcome to the data modeling session. So let me introduce myself first. My name is Vipul and I'm a data architect. I have a total of 11 years experience in this field of data modeling, the database designing, requirement gathering, analysis, converting it into designs for different databases, and currently I'm also working as an ETL and a BI specialist. So well, this training is all about the data models, the data modeling, how to really make a very effective models when you work on a real-time projects in your company, how to analyze the requirements, how to convert that into a conceptual, logical, and the physical data model. Okay, so let's start. We're going to start with the very basic part. Some of you might have heard a few things around it, because I assume you guys are from different backgrounds. So, but still I would like to start from very basic. Okay, so the very first thing, what is a data model? So data model, it's a collection of conceptual tools for describing data and the data relationships. It's a conceptual representation of structures required for database and is very powerful in expressing and communicating the business requirements. It visually represents the nature of data, business rules governing the data, and how it will be organized in the database. A data model provides a way to describe the design of a database at the physical, logical, and view levels. Okay, don't worry if you can't just understand everything. It's a theoretical part. Now let me try to just make a little easier for you to understand. So if we have to really define a data model to a layman, in the layman terms, a data model is nothing but the structure of the data. Okay, the way we want to store the data in a database, that's all is called as a data model. When we try to store, we first design the data. Now these are some basic definitions. What is a data? Known facts that can be recorded and that have some implicit meaning. What is a database? A collection of related data. Mini world, some part of real world about which data is stored in a database. For example, student grades and transcripts in a university. So some kind of a small area, we can call it some kind of a subject area that can be called as, that's called as mini world. What is a DBMS now? DBMS is something that manages the database. So if I have a big database like a file, the systems are there, or if I have the data collected in some kind of tables or something, I just need some kind of a software to manage all of that data, and that's what is called as DBMS, the database management systems. And what is a database system then? Database system is the whole set of applications, we can say, the ones which are really, let's say, reading the data from that DBMS, and we are putting the data back in through that DBMS. So the set of applications as well as the DBMS, that would be called as a database system. Now here's some a brief about the file system versus DBMS. Before that, I think I would like to really tell you more about the need to why we really need a data model. Let me see if I have that slide here. Yes, that's where it is. So well, basically, before we jump to the DBMS, it is good to understand more about the data model. What happens, when we try to store the data in the database in form of files, in form of any unstructured raw form, which does not have a particular structure, we are not able to relate a particular set of data to the other set of data. Okay, something we can think of like, like a barren piece of land where we want to really make some kind of a structure, a building or a home or something. We really have to, first of all, make a map. We have to design, make some high level design where we say, okay, here's going to be my room, here's going to be my the living room, here's going to be my kitchen, the toilets or whatever. So why we do that? Because we want to really use that particular area, that particular room for a specific purpose. We just can't make, the whole piece of land we can't use for the for everything. So we divide it. And now this kind of, and how that helps then, because we place certain things in that particular area, we live, a little, we do different activities in that area, let's say. So if we make a kitchen, we are going to really do the cooking there, of course. Same is the case for the bedroom, and we do whatever different activities as per the need. So same is the case for a data model. When we try to make a, when we try to store the data in the database, we try to give it a structure that this is how I would like to store my data. So we divide the data into different sets or rooms. Okay, those are sometimes, now if we go back in the data modeling world, we can call them as an entity, or if we are really talking about a DBMS, they will be called as a table or something, some kind of an object where we are storing the data. And then those objects are going to interact with each other. Just like the doorways are there in your home or your building, you have a doorway to go from one room to the other. Here you have the other objects in form of constraints, the foreign keys, or you have then the languages like SQL, PL SQL to interact between those objects, go from one object to the other to find out what data it is. Okay, so this is a very basic need of data modeling. If we now just go through some of the theoretical concepts here, it's a graphical representation of complex real-world data structures, and it facilitates interaction among the designer, the application programmer, and the end user. So who all are these parties? The designer basically is the one who is a data modeler himself, the one who is going to design the database by gathering the requirements and translating them into form of an entity relationship diagram. And the application programmer, he is the one who is going to use the database, the design that has been made by the designer. The application programmer writes the code behind that application for that particular set of tables or the design, and makes an application. And finally, there is the end user. So here, the end user would be the end user of the application, or if we are talking about a company, we are actually talking more about the testers, basically. Okay, they have different views and the needs for the data, and the data, because it's if we don't really have a data model, we just cannot present something. We can't really tell the design. So everybody needs some kind of a design on a high level. Okay, it organizes data for various uses, we have discussed already. Now let's go back to the slide where we left. So we have now understood about what is a data model and what is the need. And we have also seen the definition of a DBMS. DBMS is a software which actually manages a data model, a software which is going to manage the database created out of the design of a data model. So here is a brief description of the difference of the file system and the DBMS. It also would help us understand that why would DBMS be used when we already have the data which can be stored in form of a file system. So let's say a company has 500 GB of data on employees, department, products, sales, etc. Okay, all of this data is accessed concurrently by several employees.
So what is the need then? Now, when we are trying to query the data, it has to be answered back very quickly. And it can't be really done in a file system. If we have the data getting stored in form of plain files, if we have a data being stored in form of an Excel sheets or an Access, we can't just access it as quickly as we can using a DBMS. Okay, that's number one. Then whatever changes being made by the data by different users, they should be applied consistently. Now, in case of a file system, if we are one user is applying something and the other user also has applied something, and as soon as they save, the previous user's changes may get lost. So let's say I do some change in the file system, the other user overwrites it, then what about the changes that I made? So there is no such kind of logging or something that we can do in case of a file system to find out who has done what, right? And whereas in case of a DBMS, when we try to interact with DBMS, then every user gets logged. The record, there is a record of everybody, whosoever is doing the change in the DBMS. And then what else? Then there is a security that is enforced in case of a DBMS. In case of a file, we do not have any security. We can open the file, we can do whatever we like to and save it back. If we want to delete the data, we want to change the data, we can do that. In case of a DBMS, we can grant the permissions, we can grant the roles to a particular user. Okay, so let's say I have a user who is just a tester, who is a part of the testing team. Now I can grant him a role that he will not be able to edit the data. He will not be able to change the data. Whereas the people who are application programmers or the designers, they would have the full access to the data to read, write, copy, whatever stuff they want to do. So these kind of securities can be set in case of DBMS. Okay, some more points about what are the drawbacks of storing in file system. Most of it we have seen, so let's go again here quickly. 500 GB of main memory not available to hold data, so it must be stored on secondary storage devices. Okay, even if 500 GB is available with 32-bit addressing, we cannot refer directly to more than 4 GB of data. So obviously, with the more the amount of data is there, more difficult it would be to handle it using a file system. And then there is a data redundancy and inconsistency issues. Now, what happens in case of a file system? We cannot have any kind of constraints enforcement, which means if I have a file, I can put the data in it, but that data can repeat. If let's say I'm inserting the data of let's say the customers, or let's say the employees of an organization, I can put the data of same employee several times inside a file. There is nothing that can stop me. The database does not, the file system does not have any kind of a constraint to do that. Whereas in case of a database system, the DBMS or any particular database system, there we have the concepts of constraints, the primary keys, the unique keys, something to control the data redundancy. And that kind of redundancies are usually managed using the normalization technique in the data modeling. That will come to, of course, when we go in the lectures, we'll understand completely how we do the normalization. Okay, then we have multiple file formats, duplication of information in different files. So that, of course, we have discussed, that would be there if we are using a file system. Special program to answer each query user may ask. That's very difficult in case of a file system. Whereas in case of a DBMS, we have a SQL, some kind of a structured language. And then integrity problems, constraints get buried in program code rather than being stated explicitly, hard to add new constraint or change existing ones. So in case of a file system, it's actually not possible to do much of the constraining. Okay, So that kind of constraints we try to manage within the program code, which is not really an efficient way. Okay. Now here comes who are the people who work with databases. So now this is about more of a group of people. I'm sure everybody who has joined this session would be from different backgrounds. Some would be working, or some may be really just entering this field as a altogether as a fresher or somebody. So just to give a background now about when the data modeler works, who are the people who are involved within in a company. So firstly, the database implementers, the designers, they are the modelers themselves, the ones who are his own team who is working very actively on a database system. And this team itself, if it's a very big organization, the team gets divided into two parts. There is a team who manages only the OLTP part, online transaction processing. That's called as a transactional databases, in which an application is continuously inserting the data in the database. The transactions are happening. Okay, let's take an example of Amazon, eBay, anywhere where we use an application. Now behind that application, whatever database they would have, that would be an OLTP application, OLTP database. Because on daily basis, continuously in the real time, as the customers are ordering the stuff, the data is going inside the database. Transactions are happening continuously. Now, once the transactions have happened, the data get transferred to a OLAP. That's called data warehouse. That's from where the analysis or the reports are pulled out by the higher management. If they want to find out, let's say, that how many orders were placed by a particular customer in so and so period. So this kind of historical data is stored over there. So now that kind of a model, modeling, the so-called dimensional modeling, if it's really a big organization, there are a different set of people who do the dimensional modeling as compared to the ones who do the transactional modeling, the relational modeling. Okay, so this team is also divided sometimes. And if it's a medium-sized organization, then usually it's the same team. It's a data modelers team who do both the relational as well as the dimensional part. Then there are DBAs, database administrators, who actually work on managing the database itself, really the internals of database, let's say, the people who really work on the storage of the database, do the memory allocations, take the backups of the data, make the instances, do the server configurations, everything about, the internal, let's call it like they work on, you have a vehicle, who are the people who are really working on the engine part, the people who are really, kind of trying to fix the insides of a vehicle. So those are the people who called as DBAs, database administrators. And then you have the application programmers. The programmers are the one who actually build the application. So what is the end purpose of a database? The database that we make, the data modeling that we do, or when we create the database, we finally deliver it to an application programmer. So the delivery is it's an input for those programmers who are going to now finally write a piece of code in any of the languages, in Java or whatever language they are using, and then they will make an application. Okay. And then the end users are more of the people who use that application. If we are talking within the organization, it is a set of business analysts and the testers who are going to finally test those applications. Okay, then we have the database languages now. How do we interact with the database? So we have firstly the DDL, the data definition language, something that is that helps us to form the structure, form an object, create an object, delete an object, modify an object. Okay, that kind of work is done using the DDL, data definition language. Let's say I want to create a table inside a database. I want to create a constraint, drop a constraint. All these will be done using the DDL statements. We will come to it. There will be a separate session about DDL, DML, DCL. Okay, DML, so once the objects are created, once the design is ready, the data model is ready, all the objects have been installed in the database. Now we have to start inserting the data in those objects. Or we want to delete the data. We want to retrieve the data. The data that is stored, we are trying to just combine a certain set of objects and we're trying to retrieve it, or we are trying to update. All of that work will be done using the DML, the data manipulation language. And then there is a data control language for all the security aspects, where we try to restrict certain users to see or use a particular set of objects, whereas other users should not. That kind of a job is done using the DCL. Right, we have already seen the need of data modeling. We don't have to go back here. We can go now further about the types of data models. So now we try to understand something on a very high level about what is the need of data model. Further, if we try to divide a data model, what we find is that in any particular given organization, when the need of data modeling arises, first of all, the data model is made on a very high level. Okay, so usually it starts from a business analyst, the people who are responsible to give the requirements for a particular business, for a particular area, let's say, or an application that they want to make. Okay, let's take an example of Gmail application. Most of us are, aware about the Gmail. It's a very user-friendly email system. All of us use every day. So if, let's say, I have to make a data model for a Gmail application, then what is usually would be the process in any given organization? First of all, the business analysts are going to gather the requirements that how this application should look like. What will be there on the front page? This will be my inbox section. Here all the mails will be gathered together. On the left panel, I would have the inbox, the sent items, the drafts. If I click on sent items, then I would see the mails that I have sent. If I click on particular folders, then I can see the mails that are grouped, which I have put in one folder. So all of this, they try to put in something called as BRD, Business Requirement Document. They capture the requirements. Once the requirements are captured, they pass it on to the system analyst, the people who are finally going to understand from the system perspective all about the requirements gathered by the business analyst. Okay, so they are the guys who have the knowledge about what language has to be used, whether it has to be Java, whether it has to be C#, VB, whatever stuff. And they also are aware about what technology on the DBMS side we will be using, whether Oracle, SQL, or if there is a lot of scope of data warehousing, they may go for Teradata. These days it's very popular. So once the system analyst understands everything, now he comes up with something called as SRS, System Requirement Specification. In some companies, it's also called as DLD. That's called Detailed Level Diagram. Okay. Here now, what is actually SRS or DLD? It's more of how the whole system would work. So for, let's say that again, the given Gmail application, there will be a class model made. That if it's an inbox system, inside the inbox, these are all the mails, then let's make one class. I'm sure some of you might be able to relate when I say the class here. I'm talking about some of the object-oriented languages like Java or something, where we make the classes. But don't worry if you cannot. I'm just trying to relate a few things here. So So that's particularly SRS is the document where we try to give from the system perspective how the whole system will work like. So they make the class models, they make the the object models, and they define really how the piece of interaction, how the application would actually interact with the database, whether it will be using a middle layer, it's a 3-tier architecture, or it's a just simple 2-tier architecture. Okay, so we'll discuss all of that I'm talking about, but here just to give you an idea about what an SRS does. Once the SRS is made, then it is given to the data modeler. Now here starts the job of a modeler to finally understand the requirement from the system analyst, or it could be even the application programmers. These days, popularly the tech leads are there, the team leads who actually take up the charge of passing on the requirements. And after the requirements are gathered, then the data modeler makes a very high level design. Okay, that's like you can call it the first draft design that he makes. That's called as the conceptual model. The very first model that you see here, it says what the system is about. His very first understanding about the system, what the whole system is doing. Okay, it does not have any details about the attributes or the relationships or this or that. It just have a very high level, like you can say for a Gmail application, he will make a set of 4 boxes. He'll make a one box called as inbox. He'll make another box called as mail, and they'll make sent items. He'll make drafts, and then he'll connect using some relationships. That's all. Conceptual model is done. Then once he understand all the requirements in detail, he makes the logical model. He converts the conceptual model into a logical model where he tries to put as much detail as possible. He puts all kinds of attributes in it. He puts what are the different data types for each of those attributes. He puts all the relationships between the entities. Everything is done in the logical model. Now, till logical model, he may not really worry about the database management system. Okay, the logical model is completely independent of any particular DBMS. The conceptual and logical are all just high-level models. They just describe the system as a whole. They really do not talk about the technical aspects of any particular model. Now, the third type of model, that the physical model, that's where the actual, the system specification starts, that what database system has to be used, whether it has to be Oracle, whether it has to be SQL Server or some other database. So a physical model will always be mapped to a one particular DBMS. Okay, this particular DBMS is where all the objects that he has made will be finally installed. Okay, again, it is converted from a logical model, and once the conversion happens, we try to modify that particular model as per the database that we have chosen. If we have chosen, let's say, SQL Server, then there would be a set of data types available in SQL Server. If we are using the Oracle, we would use those particular data types. Okay, and finally we will be installing that in our DBMS system. A graphical representation of how the whole process is. We have all these schemas. The schemas can be thought of like the end users, or the people who are really gathering the requirements. So they first of all, with all of their inputs, the conceptual model is made, and then the logical model, it's converted into a logical model, and finally into the physical data model. Again, a small representation of who does what in a company. Now, conceptual data model, this is a very high level diagram or a model. What is made is something that will be used by a business analyst or a system analyst. It is of course made by a data modeler, but the end users of this model is not really the application programmers. It is more of a understanding type of a model. So whatever is given by the business analyst or system analyst, either they themselves might like to make some draft rough diagram and present it, or they may engage a data modeler to make it and discuss it. Okay, once the conceptual model is made, then the logical model that is worked upon by DA, the data architect or the data modeler, who gives a proper definition to it, to each and every object in it. So the end users of logical data modeler model is actually the data modeler themselves. And then once it is converted to a physical data model, now that is something, an ownership of database administrator. Why database administrator? Because they are the ones who are really taking care of the database as a whole. They are the ones who works on the, managing and maintaining all the objects, taking the backups, doing the storage, memory allocations and whatnot. Okay, so database administrators are the ones who actually work on the physical side. Okay, finally, we have spoken a lot about the data model now, what is the need and what a data model is and why we should make a data model. So here comes the, very first picture of how the data model look like really. So there are generally a few terminologies used, and many organizations have, in the data modeling world, they have different terminologies. We will use some standard ones that are used all across and understood very well. So firstly, there is something called as an entity, and there is a relationship between them. This is how a very simple model would look like. If, let's say, I have to make a model between let me see if I have. So if I have to make a model between an employee and a department, where I say in simple terms that multiple employees work in one particular department in an organization, then how would I make the model out of it? I would make two different entities, one as department, another as employee, and we will just connect those two using a line. We'll draw a line between them, and on the end where I have multiple instances of an object, we'll create a small triangle. As you see on the top of an employee entity, there is a small triangle. What that triangle denotes? It's the multiple instances attached to one instance of the previous entity. So if we have to read out this particular model, it will be read out as department has employees working in it. And then we can even read it out from the reverse side. We can read out saying an employee works in one particular department. If we look at the department side, we do not have this triangle there on the top. We have it on the employee side. And because we do not have the triangle, it is denoting the single instance of that entity. It is denoting the one side. So if we read out, we will say employee works in one department. And on the reverse side, if we read out, we will say department has multiple employees. Okay, that's a very simple representation of an entity and the relationship between them. So just to now wanted to give you an example first before we go on the theoretical part. So here now it would be easy to understand what is an entity. It's a real world thing or interaction between two or more real world things. Attribute, an atomic piece of information that we need to know about entities. So if we go back here, now inside these entities, you see there is an attribute. Department entity has an attribute called as department ID. Similarly, employee entity has an attribute called as employee ID. What are these attributes? Attributes is a description about that entity, something which is going to explain more about that entity. If we have made an entity called as employee, then employee ID would be one of the attribute, which is here a primary key. We'll discuss what is a primary key and unique keys. What else can be there? We can have the name of the employee stored in this entity. We can have the contact address. We can have contact number. We can have email ID and everything related to employee. All of those will become part of the attributes of an entity. Okay, and then we have the relationship, which defines how entities depend on each other in terms of why the entities depend on each other and what that relationship is. So we define the cardinality of relationship. So again, not to get too much deep into the terminology, because as we go in the sessions, we'll discuss each and everything in detail. What is a cardinality, what is optionality, and everything. But here it's just a simple example of the entity and the relationship between them. This line that you see between the department and the employee, this line is called as a relationship. Okay, that's in the logical terms. When the same thing gets converted into the physical side, on the physical side, it will be called as a foreign key constraint. There'll be an altogether a different object made in the database. All right, we'll discuss that in the future sessions. All right. So again, it's just repeating the same thing. Given that employee is an entity, department is an entity, every employee is identified by unique employee number. A department is identified by unique department number, and then there are multiple employees working in one department. Okay, this can be thought of more as a solution that has been made out of a one-line requirement. The one-line requirement that was stated was, please make a ER diagram or a data model for a small company which has a set of departments and employees working in each of those departments, multiple employees working in each of those departments. So just one piece, one single line of requirement. If we had to make a data model, that's how it will look like. All right. I'm sure it is much more easier to understand when we really take the examples. Okay, so this is going to be one of the major part of this whole training. There will be a lot of examples and case studies. I will not really be teaching you much of the theoretical concepts. I would be, of course, but it would not be really for a longer time. Let's say it would last in, let's say, another couple of days. And after that, we will directly jump onto the real-time projects, the data modeling projects, which I have, been gathering all through my experience in previous companies. So we'll work on all those real-time projects. And so once we are really working in this project, in the practical projects, that's when the learning is, it becomes very fast and effective. It becomes much more efficient. All right. Okay. Changing from one tool to other is not more than a few hours job. What is more important is to learn and get the skill set of data modeling. The one who is a data modeler, when he is given a piece of a set of a requirement, he should be able to translate that in form of a data model, even on a piece of pen and paper. That in form of a tool, because tool, all that it does is it facilitates us, it makes our job easy to understand a diagram. Every tool has all that same features of making the boxes, the relationships between them, defining the attributes, converting from one model to the other, finally generating the SQL scripts and whatnot. So we are going to cover these two tools here in the training, CA Erwin as well as SAP Power Designer, so that you guys can just, go with whatever is the requirement in your projects or wherever you want to, let's say, apply if you're shifting or into another field. If you have any special requirement for any other tool, let's say your company is using ER Studio or Oracle Designer or anything which something new is there, you can let me know and I will try my best to help you out there as well. The attribute of
Okay, now let's get back to the example that we were talking about. So the example that we took about the department and the employee. Now here the entities, first of all, should be always named in singular. That is just by convention, always we name every entity in singular. So if you see here, it's not departments, it's department. Similarly, although we are saying department has multiple employees, but we don't name the employee entity as with a plural. We don't say it employees, we say it just an employee, because it's denoting an instance. Every instance of a entity is denoted by this name. Okay, and then we talk about the attribute of employee, that is employee ID.
Unique identifier, primary key of employee entity is shown with a hash symbol that you see here, the department ID. It's shown with a hash, same with the employee ID. These are the primary keys of these two entities. We'll discuss more about what is a primary key, unique key. So think of entities as tables, think of attributes as columns on the table, and think of instances as rows on the tables. Now, why is this kind of statement I've tried to include here? Because many of us are already, sometimes working in a database side. Some of you might be like a PL SQL developer or might have some idea around the database. So it's easier to relate that entity is nothing but if we convert it in a database terms, it will be called as a table. And the relationship will be called as a constraint, the foreign key constraints. Anything else you